This dissertation investigates the use of whole-life carbon assessments to optimize carbon reduction for reaching net zero carbon. A case study is conducted on the adaptive reuse of Saxon Court, a first-generation office building in Milton, Keynes. The building and construction sector is the largest emitter of greenhouse gases, accounting for 39% of the global carbon emissions. To meet the global target of reaching net zero emissions by 2050, the industry needs to decarbonize our existing building assets through retrofit and reuse. The World Green Building Council states that net zero carbon buildings should adopt a whole-life carbon approach, meaning that all carbon emissions within the life cycle of a building should be addressed. This includes operational carbon from energy use in buildings and embodied carbon from building materials and construction. As shown in the graphs, research on net zero carbon buildings have grown exponentially in the past decade. However, most of these publications focus on achieving net zero carbon in new builds rather than in building reuse. This case study addresses this research gap and aims to provide a clear framework for using a whole-life carbon assessment as a tool to achieve net zero carbon in adaptive reuse building projects. The study follows a 4-step framework. Firstly, 2 design options are established, the first being the proposed scheme, which involves retrofitting the existing 3-story building and adding a 3-story extension. The alternative option is to demolish the existing building and construct a 6-story new build. A whole-life carbon assessment is then conducted using one-click LCA software to compare the embodied and operational carbon impacts. A sensitivity analysis is also conducted on a range of selected variables to investigate how they affect the whole-life carbon in both options. Examples of these variables include recycled content of steel elements, transport distance of materials, and the service lifespan of the building. Finally, the results are analyzed and assessed against industry benchmarks. The findings show that adaptive reuse has a lower whole-life carbon impact than a full new build and can meet industry standards for net zero carbon. Although the results are specific to the unique characteristics of this project, such as location, scale, and building type, the methodology and data analysis framework are transferable to other projects. By demonstrating that whole-life carbon can be optimized to reach net zero in adaptive reuse, the study aims to motivate more projects to target net zero carbon in the future.